All right, this video is going to talk about using the zero product property. And what this property basically says that if you have two products or two factors that you're multiplying, and the product of those two things equals 0, then there's two situations. A equals 0 or B can equal 0. The other situation, I guess we can also say, is that A and B equals 0. But we really just care about the fact that either one or the other is equal to 0. And so a quick example of what that could look like, if I take x minus 5 times x plus 3 equals 0, well, the only way this can be true is if x minus 5 equals 0 or x plus 3 equals 0. So if x minus 5 equals 0, we know that x equals 5. And if x plus 3 equals 0, I know x equals negative 3. So if I plug in a 5 minus 5 is 0. 0 times 8 gives me 0. If I plug in negative 3, I have negative 8 times negative 3 plus 3 is 0. So negative 8 times 0 also gives me 0. So these would be my two solutions. And again, we're exploiting the zero product property. So for this to work, one of the sides of your equation must be in factored form, and the other side must be equal to 0. So we're going to take a look at some examples of that. So our first example, 2p squared plus 7p plus 2 equals 2p. So when we look at this, I know it's a quadratic because the leading degree is 2, but it's not set equal to 0. So we're going to use our properties of equality, subtract 2p from both sides. We get 2p squared plus 5p plus 2 equals 0. Now, when you're doing this, you always want to make sure that the leading term is always positive. So now I'm going to go into my factoring methods. It's a quadratic, so I'm going to do 4p squared on the top, my a times my c, 5p down, and so I know my numbers will be 4p, 1p. And so now I'm just factoring this expression. So now I have factor out the 2p, p plus 2. This will be p plus 2. So now we're solving, we're not just factoring. So I have my factored form. I'm going to set each equal to 0. So p equals negative 2, or 2p plus 1 has to be equal to 0. 2p equals negative 1, p equals negative 1/2. And so my two solutions would be negative 2 and negative 1/2. Looking at example 2, this one gets a little bit more complicated. We can look at it two different ways. So if we look at the left-hand side and the right-hand side, we could start with multiplying out x plus 5 and 2x minus 1, distributing the 3, and then getting everything equal to 0. But I want you to notice that this and this are the same. And so if I subtract my right-hand side, this is going to make the problem a little bit easier because now I have a common factor between these two terms. So I can factor out an x plus 5. That's going to leave me with a 2x minus 1. And then I'm going to have a minus 3. So again, this is because I factored out the x plus 5 from both x plus 5 times 2x minus 1 and minus 3 times x plus 5. So simplifying, I get x plus 5, 2x minus 4 equals 0. And now I can set each factor equal to 0. So x is going to equal to negative 5, or x will equal positive 2. So those are my two solutions for this equation. One last example. In this case, example 3, 2x minus 1 times x plus 2 equals 5 minus 2x. Notice this isn't like the problem that we just did where there was a common factor that you can look for. In this case, there's no common factor that we can use. So this one's going to require us to do a little bit more work. We're going to distribute FOIL 2x squared. This will give me a minus x plus 4x, so plus 3x minus 2 equals 5 minus 2x. I'm going to get everything equal to 0, so I would have 2x squared. Add 2x to the side, subtract 5, and we get our new equation, 2x squared plus 5x minus 7 equals 0. These are the same equations, right? Just in a different form. I'm going to do my factoring methods. We will have negative 14x squared on the top, 5x on the bottom, and so my two numbers would be 7x minus 2x. Split the middle term. And so if I split the middle term, I'm going to factor by grouping. I see I can factor out an x. And now notice I need a plus 7. I have a minus 7, so that's going to indicate that I'm going to factor out a negative sign. And that's going to force me to have 2x plus 7 in my second term. Again, these should always match if we factor by grouping. This will leave x minus 1 once I factor out the 2x plus 7. And so solving, x minus 1 equals 0, so x equals 1. 2x plus 7 can be 0, so x will equal negative 7 halves. So again, the things we need to remember if we're using the zero product property is has to be in factored form. So there should be no plus signs between terms, okay? And then we know it has to be equal to 0. Once that happens, you're going to set each factor equal to 0 and solve for the variable.